Hello everyone, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. In this video, we will see what is loss function. So, as we all know, when we train a network model, a deep network model, or it might be a machine learning model, how do we know that the machine performs actually well or does it make any mistake? So, the answer for this lies in a technique called loss function. So what is loss function? Loss function is nothing but it is a measure of tendency that is the difference between the actual output and the model's predicted output. So this is called loss function. In this video, we will explore what loss function is, why it is very important in deep learning, and what are the different loss functions available in deep learning. Let's explore what is loss function. So let's see what is loss function. So the problem is when in a convolution neural network, sometimes it gives wrong predictions even after so much training the model. And how does the model know how wrong it is? How does the network learns from its mistakes? How does it improves accuracy step by step? For example, let us consider the given input image is a fish model. It has been trained by the CNN, that is your convolution neural network, and the model predicts the output as when a image is given, the model predicts it as bird. So it is actually a fish. So how does the network learn this from the mistake? So for all these types of questions, the loss function is the answer. So loss function is nothing but it gives the measure between that is the error between the predicted output and the actual input. So the loss function is nothing but it is a mathematical function that quantifies the error by measuring the difference between the predicted output and the actual output. So as I told you, the loss function is nothing but it is the difference between the actual output and the predicted output. It is just the difference between a predicted and the actual. For example, if the model has predicted the house price is 50 lakhs, but your actual price, that is the land value, is 55 lakhs, the difference is nothing but the difference of the actual and the output, which is 5 lakh. So that is the error in terms of model prediction. So the loss function tells us if there is a lower loss, it is a better model, and if it is higher loss, then it is a poor predicted model. So this is about the loss function. So in the convolution neural network, we have different types of loss functions. So if you take image classification, like as we see in the previous video, so when if it is cat versus dog, then the loss function that could be used is cross-entropy. Suppose if it is a binary classification like yes or no, or defective or not defective, spam, not spam. So for all these types of classification, we have to use binary cross-entropy. If it is a multi-class classification, like for example the digits from 0 to 9 or some other data, then we have to use the categorical cross-entropy loss function. If the task type is a regression like age prediction, then we have to go for mean squared error loss functions. So for different task types, we have different loss functions to improve the model accuracy. So the first loss function that we are going to see is mean squared error, which is commonly called as MSSE. So this is mainly used in regression based CNN tasks. So here it penalizes the large error. So if you see the formula itself, it is going to square the loss, that is the error function predicted and the actual output. So it penalizes large errors more. It is not used for ideal. It is not ideal for classification purpose. It can be used only for regression based CNN classifications. The next loss function we are going to see is about binary cross entropy, which is mainly used for binary classification. That is, if the output is yes or no, defective or not defective, spam or not spam. So for the least classification types, we can use binary entropy. So the binary classification is the formula to find the binary entropy is we have to calculate the logarithm of the predicted output plus your model's output. So this forms your binary cross entropy loss.